Hey everyone, welcome back to the channel. And today's lesson, we're diving into something super useful: how to solve quadratic inequalities. If you've ever wondered how to figure out where a parabola is above or below the x-axis, or what less than zero really means in a quadratic context, this video is for you. So you have been solving linear inequalities. For example, x minus 2 is less than 0 and x is less than 2. So that's a linear inequality. But how do you solve an inequality like this? X squared minus 5x plus 6. And let's say, okay, let's make it less than 0. So I'll break down into steps and go through some examples in the later part of the video as well. So you'll feel confident tackling these problems on your own. So grab on your notebooks and let's get started, right? So first thing you need to do is just factorize it, which is x minus 2 and x minus 3 and less than 0. Okay, so after this, the common mistake which beginners make is like they put both factors less than 0. No, that's not the case. So there are ways in which you can solve it. Like way one is like you can make a number line and put the roots on the x-axis, like this is a 2 and this is a 3. And then decide, take any value which is below 2, take any value which is above 3, or take any value which is within 2 and 3 to decide which region to pick. But I prefer the parabola way. So when you have the roots from the factors, sketch a parabola like this, okay? And then decide on the basis of this. Now, when they say that this quadratic expression, or you can say more relatively, like function, is less than 0, it means where your y is below 0. Now, listen to me carefully. This thing means that y is less than 0. Where is y less than 0? Below the x-axis. So in this case, this will be your required region. So that means that your answer is within this and this. So you don't need to put this notation, like the parabola is enough. You're studying quadratics, so in quadratics, it's like really useful to sketch a parabola and then decide what is the desired region. So the answer is x should be within 3 and a 2. That's your answer. Okay. Okay, so read the syllabus text like they're saying find the solution set of the quadratic inequalities either graphically or algebraically. So we'll be solving some graphical portions later on, but right now this lesson is all focused on solving it algebraically. Solution should be written in the correct form. So keep in mind that you're familiar with the how do you give the solutions. Like this same solution can also be given as like, or you can say x is greater than 2 or x is less than 3. Do you connect? This is the same answer, just written slightly differently. Okay. So now I'm going to solve another one. Let's say x squared minus 4x and put it greater than equal to 0. So I'm just solving some questions for you. Okay. So I'm going to zoom it out a bit. Okay. So how do you factor this out? Let's factorize it: x minus 4 and greater than equal to 0. So one of the solution is always sketch a parabola. So one of the factors x. So the root is going to be 0. And the other factor is x minus 4. So the root will be a 4. So you sketch a parabola and then decide. So these are the required regions. I hope you understand reason. These are the regions, like you are looking for those regions where your y is greater than equal to 0. So where is y greater than equal to 0? Above the x-axis. So in this case, you're looking for the region which is above x-axis. And in this, you're looking for a region which is below x-axis, right? So look, I have shaded the same regions. Look at this thing and these regions. So how do you give your final solution? So x should be less than equal to 0 or x should be greater than equal to 4. So I have given my answers like this, like given in the criteria. Now I'll solve 3 more problems and you can relate to those, and those will help you like really master the skill of solving quadratic inequalities. Okay, so let's begin with problem 1. If you want to give it a go ahead, pause the video and try it on your own. Okay, now let's check the solution. So 2x plus 3 less than x squared plus x. It needs some rearrangement. So subtract 2x and 3 on both sides. So this becomes x squared minus x minus 3. And that's the same thing. I can write it like this. Okay, so this is not a factorizable situation. I mean, many times, most of the times, you get a factorizable expression, but this one is not. So what I can do, I can just pick this expression. Let me just do it here. I can apply the quadratic formula. So x will be minus b plus minus b squared minus 4ac and divide the whole thing with the 2a. Sometimes the exam question might say give your answer in exact forms. So you can consider this question to be like that. So I'm not going to be putting decimal values over here. 1 plus 12, that's a 13 over 2. So, well, I've got my roots. One of the roots is like 1 minus root 13 divide 2. And the other is 1 plus root 13 divide 2, right? Okay, sketch a parabola and put your x-intercepts. The word is x-intercepts. These are the roots. 1 minus root 3 divide 2 and 1 plus root, oh, my bad, 13, right? 13 divide 2. So now we know that this is the region where your parabola is positive, greater than 0. So how do you write your answers? The correct way is x should be less than 1 minus root 13 divide 2, or x should be above 1 plus root 13 divide 2. Because these are the region where this quadratic function is positive above the x-axis. Problem 2. Solve the inequality x squared minus 3x. So let's just rearrange it first because it needs rearrangement. Minus 4x plus 12 and less than equal to 0. This is x squared minus 7x plus 12 and less than equal to 0. And this one is a factorizable one, minus 4x minus 3x plus 12. So situations can be factorizable or unfactorizable. You need to be able to solve them in both situations. X minus 4 less than equal to 0. I'm just factoring this quadratic. This is what I get. And my roots are sketch a parabola like this. It's just a rough sketch. One of them is a 3 and the 4. So what is the region where your parabola is below the x-axis? This is the region, right? Below the x-axis, the negative region. So x should be within 4 and a 3. If you're wondering why am I putting less than equal sometimes and not either less or greater, it depends on the sign of the inequality which is given in the very beginning. So in this case, it was like 4 and less, 3 or more, right? Final problem. Solve the inequality x squared over 4 greater than x minus 1. Okay, so we need to rearrange it first. So let's time 4 on both sides and standardize it like this, minus 4x plus 4 greater than 0. This is a factorizable case, x minus 2 whole squared. It's a perfect square. So how do you sketch it? In the perfect square situation, like the complete square, the x-axis is tangent to the curve. So they want the region which is greater than 0. So since this is 2, so one of the solution can be below 2 or the other solution is greater than 2. So not equal. Since if you put it equal, then that is on the x-axis and this inequality does not have an equal sign over here. So that's the final answer, right? And that's it. Now you know how to solve quadratic inequality by factoring, sketching, testing intervals. Just remember it all comes down to understanding the sign of the expression across different intervals. So if this helped you out, Give the video a thumbs up and consider subscribing for more math tutorials just like this. Got any question or want to see more examples? Drop them in the comments. I'd love to help. Thanks for watching. Over and out.